we are back again for Unit 2B review. I am Algebra 2, right? Everybody's excited, they're thrilled. I can see the excitement on their faces. We're going to work on problems 9 through 13 or 14, maybe, depending on how long it takes. We'll try to limit this to an 8-minute video. We went a little long last time. We don't want to do that because we don't want to bore you, right? All right. Rewrite the rational function g of x equals 7x minus 12 in the form g of x equals c plus r over x, where c is a constant and r is an integer. What is the end behavior of f of x? Remember how we did this? We said that this is the same as 7x over x minus 12 over x. And what happens to the 7x over x? It's just 7.
7 plus 12 over x.
Or minus 12 over x, but that's okay, all right? Because what happens to this part when we get x equals, x is really, really, really large? It goes to 0, it gets close to 0, it gets close to nothing. It becomes infinitesimally small, and the entire function gets close to 7. So we're going to say g of x is equal to 7 minus 12 over x. That's what it asks us to do, rewrite it. And then the end behavior. As x gets large,
In the positive and negative direction, y gets closer to 7.
right. As x gets large in the positive and negative directions, y gets close to 7. Painless. Now we're going to solve some rational equations, right? Rational equations have denominators that have variables in them. And the way I taught you to do this is multiply both sides of the equation by both denominators. 4 plus x is the denominator here, and 4 minus x is the denominator here. Because when you have a fraction, it's just the numerator divided by the denominator. So it means we have division by 4 minus x and multiplication by 4 minus x that cancel each other out. And over here we have multiplication by 4 plus x and division by 4 plus x that cancel each other out. And that leaves us with 4 times 4 plus x equals 5 times 4 minus x. And then everybody's favorite, the distributive property, is 16 plus 4x. And the distributive property is 20 minus 5x. And then if we add 5x to both sides, we get 16 plus 9x equals 20. And if we subtract 16 from both sides, we get 9x equals 4. And if we divide both sides by 9, we get x equals 4/9. We need to go back and make sure that if we plug in the 4/9, it doesn't make the denominator 0 in the original problem. It doesn't. So this is our solution. The number you would plug in for x to make that equation true. Likewise, we're going to multiply both sides of the equation by both denominators. 4x minus 5 is this denominator. 3 plus x is this denominator. We're multiplying both sides of the equation by those two denominators. So that on this side we have multiplication by 3 plus x, division by 3 plus x that cancel each other. On this side we have 4x minus 5 division, 4x minus 5 multiplication that cancel each other. And that leaves us with negative 2 times 4x minus 5 equals 1 times 3 plus x. We're going to distribute and get negative 8x plus 10 equals 1 times 3 plus x is just 3 plus x. I'm going to add the 8x to both sides and get 3 plus 9x on this side equals 10. I'm going to subtract the 3 from both sides, and I'm going to get 7 equals 9x. I'm going to divide both sides by 9 and get x equals 7/9. If I go back and plug in, I will see that neither of those would have a 0 in the denominator if I plug in 7/9. So this is my answer, my solution. Some people were confused yesterday when they got this next problem because they didn't understand. Solve for x and identify all the x values that make the equation true are the same thing. So we do the same thing. We're just going to solve it. Multiply both sides by both denominators. So the division by x plus 8 and the multiplication by x plus 8 cancel. Division by x plus 2, multiplication by x plus 2 cancel. That leaves me with 2 times x plus 2 on the left and 1 times x plus 8 on the right. Distribute and get 2x plus 4 equals 1 times x plus a is just x plus 8. Subtract x from both sides, get x plus 4 equals 8. Subtract 4 from both sides, get x equals 4. Go back and check, make sure if I plug it in, it doesn't make the denominator 0. This is a good solution. This is painless, y'all. This is so much fun. We're almost done with this. If I multiply both sides of this equation by both denominators, multiplication and division by x plus 11, cancel. Multiplication and division by x plus 5, cancel. That leaves me on the left with 5 times x plus 5 equals 1 times x plus 11. Distribute. Get 5x plus 25 equals x plus 11. Subtract x from both sides. Get 4x plus 25 equals 11. Subtract 25 from both sides. Get 4x equals negative 14. Divide both sides by 4. X equals negative 14 over 4. If you reduce that,
It's negative 3.5.
or negative 7 over 2, which is negative 3.5, either one of those is going to say it's the same answer.
So what?
I take any of it. It is very hot. It feels like we're cooking turkeys in here, right? This is what the inside of a pizza oven feels like, right?
This is so fun.
If I plug in negative 3.5 to either one of those denominators, it would not make it 0, so that's a good solution. Okay?
Yes.
This is painless. Y'all can do this. Y'all can do this test. Y'all can make good grades on the first round of this test. You can do this.
So we are getting a retake.
I hope you won't need one.
It says 25 right there, right? 5x plus 25.
Yes, 5x plus 25. There's one more problem. One more problem. We're at 7 minutes and 15 seconds.
We got a minute left. Is he back?
This next one may take more than a minute.
So? We did 9 last time.
I'm gonna go ahead and stop this and we're gonna go. We did do 9 minutes last time. So you think we can make this in 3 videos?
We have one more question left, it's okay.
Yeah.
So you wanna go a little long?
Making a whole separate video for one question.
You don't think this will destroy my likes and comments and subscriptions? My popularity on YouTube won't go down? Because I have a 9-minute video?
No bueno.
All right.
Oh my gosh.
All right. One more problem on the back. This one looks like a fun one. Jada is planning a kayak trip. She finds the expression for the time, T of S, in hours, whoops, that it takes her to paddle 10 kilometers upstream. In terms of S, the speed of the current in kilometers per hour. So here's Jada. Here's the stream. She's going upstream, right? And this is the current going backstream. And the current's going S miles per hour, right? Listen. Shh. The time in terms of the current is 10 over 5.5 minus S. So in this case, if the current was 5.5 miles per hour, this is S right here, but if S was 5.5, what would happen here? If S was 5.5, this would be time equals distance over rate. And what would the rate be? And that's because Jada can paddle at 5.5 miles per hour. That's what this tells me. When I look at this function, it means she can paddle in still water at 5.5 miles per hour. So if she's paddling against a 5.5 mile per hour current, she's going exactly 0 miles per hour. She's paddling and not going anywhere, right? And so when it says, where's the vertical asymptote? The vertical asymptote is what makes the denominator 0. So you set it equal to 0 and solve. So the vertical asymptote is S equals 5.5.
What's 5.5 minus S?
That's 5.5 minus S, yes. How do you know? We just showed how we know. We set the denominator equals 0 and solve. And what does it mean in this situation? This means that Jada can paddle the kayak 5.5 miles per hour when there's no current. What would happen if the current was greater than 5.5 miles per hour?
Going faster.
Do what?
Going faster.
If it was greater than 5 miles per hour and she's going upstream, it's working against her, she would actually be going backwards even though she was paddling as hard as she could.
Can you speed it up? Like,
Yes. What if it's going less than 5.5 miles per hour?
what does that say?
This means Jada can paddle a kayak at 5.5 miles per hour when there is no current.
Okay.
If the current's going less than 5 miles per hour and Jada's paddling at 5.5 miles per hour, then she can actually move upstream. Okay? If the current's moving greater than 5.5 miles per hour, it's actually pushing her backwards. That's what it means. All right, we actually went 11 minutes. This might cost me. But if you haven't been bored to tears by an 11-minute math video, please like and subscribe, comment, tell all your friends on social media and in your house, right?
You got you.